So in previous class, we discussed about zero order reaction and first order reaction, right? So as well as half time reaction of zero order reaction, and also half time for the first order reaction, right? So here the mathematical expression for zero order reaction, nothing but what? X is equal to kT, right? So X is equal to kT. So zero order reaction means what? Zero order reaction means what? The rate of the reaction depends on what? Is it depends on concentration of the reactant? Yes or no? Zero order reaction. So it is independent on concentration of the reactant. Simply what we call zero order reaction means what? It is independent on concentration of the reactant, right? So here the expression is X is equal to kT, right? So for zero order reaction, X is equal to kT. Clear? So half-life period for zero order reaction nothing but here TF is equal to TF is equal to what? A by 2K, right? A by 2K. So here, so this is half-life period for zero order reaction. So first order reaction means what? A reaction is said to be a first order. The rate of the reaction depends on only one concentration term, right? Only one concentration term. Clear? Means depends on one concentration term, the concentration of the reactant, right? So here A gives products. A gives products. So A is the initial concentration in moles per liter, right? So after time t, the change in concentration we can represent in terms of x, right? So at any instant of time, the change in concentration with respect to time, that is given by t is equal to a minus x, right? A minus x. So that the rate of according to law of mass action, the rate of the reaction depends on dx by dt, that is directly proportional to the change in concentration. That's nothing but a minus x, right? A is nothing but initial concentration. X is nothing but change in concentration with respect to time, right? That will give us the concentration of the reactant, A minus X, right? So if you're solving this, so we'll get final equation. So that is expression for the expression for rate of reaction with first order, right? So that is first order expression. So that is equal to 2.303 divided by T ln A by AX, right? 2.303 divided by T natural log A by X, right? So half-life period for first order reaction is nothing but what? So finally, we're going to solve this. We'll get this. That is T of that is equal to 0.693 divided by K, right? 0.693 divided by K. Okay, this is about half-life period for first order reaction. Okay, today we are going to deal with one more, that is second order reaction. As you know that first order is nothing but what? The rate of the reaction depends on one concentration term, right? One concentration term. So second order reaction means what? The rate of the reaction depends on what? Just tell me.
Two reactants.
Yeah, two reactants or else two concentration terms, right? So maybe the two reactant service are same. So it means A is equal to B like that, or else different. A is not equal to B like that. Okay, so we have different cases here in second order reaction. So here nothing but what? The rate of the reaction depends on two concentration terms. Okay, or else two reactants. Two reactant will be same, that is the first case, or else two reactants are different, that is second case. If two reactants are same, we just follow A is equal to B. So if two reactants are different, so A is not equal to B, like that. Okay. Let us take this. The first case, A is equal to B, nothing but two reactants are same. Okay, two reactants are same. The reaction is stated to be a second order. The rate of the reaction depends on two concentration terms, right? Two concentration terms are as two reactants. Okay. So here simply take two same reactants, that is 2A give rise to product. Okay. 2A give rise to product. Wait a second. So here the same reactant we have to take, that is 2A, that gives the product. Okay. A is nothing but initial concentration. So after time t, x nothing but change in concentration, right? Change in concentration, right? At any instant of time, the concentration of the reactant is A minus x, right? At any instant of time, the concentration of the reactant will be A minus x. Clear? Here we have to take the same reactant. Two reactants are same. Got it? Don't get confused. Two reactants are same. So that I put 2A. Okay, A plus A nothing but 2A, right? 2A gives rise to product. A is the initial concentration and X is change in concentration with respect to time. Therefore, the concentration of the reactant after the time T is given by, that is equal to A minus X, right? That is equal to A minus X. Okay, you just follow the same thing, whatever you follow in first order reaction. So here, applying the law of mass action, the rate of the reaction will be given by, that is rate of reaction dx by dt is directly proportional to A square. Okay, here we have to take the same reactant, right? A into A, the concentration of two reactants, right? So A into A, that will give A square. Don't get confused. So concentration of two reactants, right? Here we have to take second order reaction, right? So the concentration of the rate of the reaction depends on two concentration terms, right? So A into A, that will give A square. Got it? Don't get confused. So dx by dt, so directly proportional to, so change in concentration with respect to time, that is A minus X, right? A minus X whole square. Got it? Change in concentration of the reactant, that is given by A minus X whole square. Got it? A minus X whole square. So dx by dt, that is equal to some k into A minus X square, where k is what? K is called? K is called what? What we called? K is nothing but what? Anybody else?
Rate constant.
Yeah, rate constant. K is nothing but a rate constant, right? K is called rate constant for the second order reaction, right? So here equation 1 we have to rewritten in the form like that. So for integration purpose, we just rearrange this equation 1. Okay, so with respect to x, integration with respect to x, okay, just take it out the x term from right side. Okay, dx by a minus x square, that is equal to k into d, right? So dx by a minus x square, that is equal to k into dt, called as equation number 2. Okay, call it as equation number 2. So now you just integrate this equation. Okay, integration equation 2, integration equation 2, you will get, so integration of dx by a minus x square, that is equal to integration of k into d, right? K into dt. So what you will get? Integration of dx divided by a minus x square. Integration of dx by a minus x square. Okay, so that will give us a minus x to the power minus 1 divided by minus 1. Okay, a minus x to the power minus 1 divided by minus 1 into minus 1. Okay, into minus 1. That is equal to kt plus I. Okay, that is equal to kt plus I. Where I is nothing but what? Integration constant, right? Where I is nothing but what? Integration constant. Here, minus 1 get cancelled each other, right? Minus 1 get cancelled each other. So a minus x to the power minus 1, we can rewritten like that, 1 over a minus x, right? 1 over a minus x. Okay, a minus x inverse, right? Simply a minus x inverse is there, so that I just written like that, 1 minus 1 divided by a minus x. Okay, so that is okay, no problem. 1 by a minus x, that is equal to kt plus I. Okay, so where as equation number 3, so where I is constant of integration. So in the beginning of the reaction, t is equal to 0, x is equal to input, t is equal to 0, x is equal to 0, in order to find out the constant, integration constant value, nothing but I value. I value you have to find out, so that we have to put t is equal to 0, x is equal to 0. Okay, if you put t is equal to 0 and x is equal to 0, just find out the value of I here. Okay, putting these values, equation 3. So here 1 minus, instead of this, right? So t is equal to 0, x is equal to 0, right? 1 minus a minus x is there, right? 1 minus a minus 0. Instead of x, you put 0, right? Similarly, instead of t, you put 0, right? kt plus I is there, right? Here, k into 0 plus I. Clear? So what is the value of I here? 1 minus a, sorry, 1 by a, right? What is the value of I here? 1 by a. Clear? put the value of I in equation 3. Okay, in equation 3, substituting this value of I in equation 3, you will get to 1 over a minus x into kt plus instead of I you put 1 by a. Okay, 1 by a, right? Kt plus 1 by a. Clear? Now just rearranging this equation. Kt that is equal to what? 1 by a minus x minus 1 by a, right? Just rearranging this equation, right? Kt is equal to 1 by a minus x minus 1 by a. Clear? So now what we are going to do now? Now what we are going to do? Any idea?
Find the equation for t, sir.
What is that? Yeah, tell me. If it's wrong, no problem. Just answer it, okay? So take LCM here, right? Kt that is equal to what? A into a minus x, right? A into a minus x. So it will give a minus into a minus x divided by a into a minus x, right? So a into a minus x, right? That is the LCM. So you will get the final answer is a minus x divided by a into a minus x. Got it? So we take LCM, you will get like this. Yeah. So now you just look at this. A minus a get cancelled, right? A minus a get cancelled, so minus into minus it becomes plus, right? So only x we have, right? Only x we have. So finally you'll get kt that is equal to x divided by a into a minus x, right? Kt divided by x a into a minus x. Here now just retain k only. So k that is equal to t. So t comes this side. So it becomes 1 over t, right? 1 over t. Here, if t comes this side, it becomes 1 over t. So we just retain k here. K is equal to 1 over t into x divided by a into a minus x, right? K is equal to 1 over t to x divided by a into a minus x. Okay, and this called as equation number 4, and this is the expression for second order reaction. Okay, this is the expression for second order reaction. So got it? Got it? Second order reaction means what? The rate of the reaction depends on two concentration terms, right? Or else two reactants, right? Concentration of the two reactants, right? Here the expression for second order reaction, that is k is equal to 1 over t into x divided by a into a minus x. Got it? So now we are going to find out the half-life period for second order reaction. Okay, half-life period for second order reaction. Okay, take the equation 4. Equation 4, that is k is equal to 1 over t into x divided by a into a minus x. So just put the value when x is equal to what? A by 2, right? When x is equal to a by 2 and t is equal to t half, right? So half-life period condition, x is equal to a by 2 and t is equal to t half, right? Half of the reaction is completed. Just put the value of x, you put a by 2, instead of t, you put half. Okay, what you will get finally? T of that is equal to what? 1 over k into a by 2 divided by a by 2 into a minus a by 2. Okay, 1 over k into a by 2. Instead of x, you put a by 2, right? A by 2 divided by a by 2 into a minus a by 2. Okay, by solving this equation, finally you will get t of is equal to 1 over k into 1 by a. Okay, by solving this equation, finally you will get t of that is equal to 1 over k into 1 by a. Okay, which means 1 by, so which means the t of is directly, sorry, it is proportional to, inversely proportional to initial concentration. A represent initial concentration, right? So the half-life period for second order reaction is inversely proportional to initial concentration of the reactant. That is 1 by A. If it is only A, that is directly proportional, right? So here 1 by A is there, which means T of of the half-life period for the second order reaction is inversely proportional to initial concentration of the reactant. So this is the T of respect to second order reaction, that is 1 over K into 1 by A, or else 1 by AK, right? 1 by AK. This is what we call 1 by AK. Got it? This is about second order reaction with respect to same reactant. Okay, with respect to same reactant, which means A is equal to B. A is equal to B. Okay. Now we will discuss about expression for the rate constant of second order reaction involving two different reactants. Okay, involving two different reactions with different initial concentration. Okay, so that is same reactant, and here this is different reactant, right? Involving two different reactants with a different initial concentration. Okay, with a different initial concentration. Both two are very, very important. Definitely, they will ask for 4 marks question. Okay, give the expression for rate of the reaction with respect to second order reaction. So with same reactant, it is different reaction with a different initial concentration. You go for this. Okay, and before that, so that was nothing but rate expression for second order with respect to same reactant, and this is with respect to different reactants with a different initial concentration. Okay, and look at this. In that case, 2A gives a product, right? Here A plus B, that gives product. Two different reactants we have, right, with different initial concentration. So that A plus B. So the first one, A plus A, that will give 2A, right? Here that is not A plus A, that is different, right? So A plus B, that will give us the product. Two different reactants are involved, right? So here initial concentration of A, that is equal to A moles per liter. So initial concentration of B, that is equal to B moles per liter. So here two different reactants are involved with different initial concentration, right? With respect to A, that is A moles per liter. With respect to B, that is B moles per liter, right? So change in concentration after time t, that is nothing but x, right? Change in concentration after time t, nothing but x moles, right? So if we take this with respect to concentration A, that is equal to what? A minus x of B. What we have? Yes, anybody else? What we can write here? Anybody else? Can you hear me? Can you hear me? Yes or no? Can you hear me?
Yes,
Anybody
sir.
else can hear? Okay, here the concentration of A, that is A minus x after time t. Similarly, the concentration of B after time t, what we have? Just tell me. A minus x. Similarly for B, what? Very simple, right? B minus x, right? B minus x. The concentration of A, that is equal to A minus x. The concentration of B, that is equal to B minus x, right? You know that the initial concentration is A with respect to reactant A, right? The initial concentration of initial concentration is B with respect to reactant B, right? Change in concentration is nothing but what? With respect to A, that is A minus x. With respect to B, that is B minus x. Very simple, okay? Don't be complicated. Okay, now applying the law of mass action, we will get so dx by dt, nothing but rate of reaction is proportional to directly proportional to reactant, right? The concentration of the reactant, right? Here we have two different reactants, that is A and B, right? We have different reactants, that is A by B, sorry, A and B, right? Concentration of A and B. So dx by dt, nothing but rate of reaction that is directly proportional to the concentration of reactants with respect to time. But after time t, what you will have A minus x with respect to concentration term A with respect to B, nothing but B minus x, right? So dx by dt, nothing but rate of reaction is directly proportional to A minus x into B minus x, right? So in that case, the first case, same reactants, that is A minus X whole square, right? A minus X whole square. Here, two different reactants are involved. So that A minus X with respect to A, B minus X with respect to B. Okay, don't get confused. Okay, next. This is the rate of reaction is that is equal to some constant K into A minus X into B minus X, right? Some constant, nothing but rate constant. K is nothing but what? Rate constant, right? So K is called a rate constant for the second order reaction. Okay, equation 1 may be rewritten in the form. So for integration purpose, just rearrange this equation with respect to x. Okay, dx divided by a minus x into b minus x, that is equal to k into t, right? Dx divided by a minus x into b minus x, that is equal to k into t. So for integration purpose, we can rearrange the equation 1, right? Equation 1, and this is called as equation number 2. Got it? So resolving the left side equation into partial fraction, this is more complicated. Don't get confused. Resolving left hand side equation into partial fraction. So you will get equation 2, maybe rewritten like that. So 1 over a minus b, 1 over a minus b into 1 by b minus x minus 1 by a minus x dx, that is equal to k into dt. Okay. So 1 by a minus b into 1 by b minus x minus 1 by a minus x dx, that is equal to k into dt. So just rearranging according to partial fraction. Okay. So integrate this equation, you will get integration with respect to dx, right? So 1 over a minus b, integration of dx divided by b minus x minus integration of 1 by a minus x. Okay, minus integration of 1 by a minus x into, sorry, here integration symbol is missing. Here also integration here. Okay, integration with respect to time, that is k into dt, right? So what you will get? So 1 by a minus b, 1 by a minus b into integration of dx divided by b minus x, that will give us minus natural log b minus x. So here integration of 1 over x, you will get ln of a minus x, right? Minus ln of a minus x. So minus symbol is there, don't get confused. So the integration you will get like that. So upon integration, you get like that. It is 1 minus a minus b, 1 minus a minus b into ln of b minus x minus ln of a minus x, that is equal to kt plus I, right? So here I just rearranging this equation. So 1 minus a minus b, so ln of a minus x minus ln of b minus x, right? Just rearranging this equation. Ln of a minus x minus ln of b minus x into kt plus I, right? Then 1 by a minus b, just again rearranging this equation. Ln of a minus x divided by b minus x, right? Ln of a minus x divided by b minus x, that is equal to kt plus I, that is equal to kt plus I. So for it as equation number 3. So that is where I is integration constant, right? You want to know the value of I, just put the condition, right? So t is equal to 0, x is equal to 0 in above equation 3. Above equation 3, what you will get? What you will get? That is 1 minus a minus b, that is equal to ln a by b. Instead of x, you put 0. Instead of t, you put a 0. Here, kt becomes 0 and a minus x nothing but a minus 0 and b minus 0, right? Only we have a by b, right? So 1 by a minus b to ln of a by b, that is equal to I. That is I value, right? Just put the value of I in the equation 3. Okay, just put the value of I in equation 3. What you will get? 1 by a minus b ln of a minus x divided by b minus x, that is equal to kt plus I is there, right? Instead of I, you put the value of I here. So what is the value of I here? 1 by a minus b into ln of a by b, right? 1 by a minus b into ln of a by b here. So kt is equal to, just rearranging this equation, 1 over a minus b into ln of ex a minus x divided by b minus x So minus 1 over a minus b ln of a by b, right? Just take the common here, that is 1 minus 1 by a minus b common. Take the common. So natural log a minus x divided by b minus x minus ln of a by b, right? So, okay, just rearranging this equation, 1 over a minus b ln of a minus x divided by b minus x into b by a. Just rearranging this equation into b by a. Okay, these are all only mathematical formulations. Okay, don't get confused. Okay, finally you will get k is equal to 2.303 divided by t into a minus b log of, okay, just convert log. So if you convert natural log into log, so you will have 2.303, right? 2.303 303 divided by t into a minus b log of t to a minus x divided by a into b minus x. And this is the expression for second order reaction with respect to different reactants with a different initial constancy. Okay, this is the expression for a second order reaction with respect to different reactants with different initial concentration. Okay, this is about chemical kinetics. Okay, so any doubts you can ask me. Do you have any doubts? Then 1 minute is there. If you have any doubts, you can ask me. I'll share the notes in a group. Okay, I will continue next class. Any doubts? Can you hear me?
Yes, sir.
So definitely they will ask for 4 marks question. At least one derivation they will ask. Okay, with respect to second order, first order, or zero order, or second order with different reactants like that. They will ask. Okay. So any doubts? Very simple. Okay, be practice it. No problem. Okay, just log out then. No problem. If you have any doubts, you can ask me. Otherwise, you log out.
Thank you, sir.
Thank you.